I try to keep my discussions as general and simple as I can, but it can get really complicated. I'm going to try to simplify this and just give you the information you need to kind of run with it and make your own decisions. So the weight balance and the weight distribution of your craft is very, very important to the way it flies and the way you actually want to fly. So let's start with the battery debate, whether a battery on top or underneath is more preferred. So my designs in my frame kind of all exclusively have the battery underneath, and that's mainly because I'm tired of breaking batteries. When I put the battery on top, it's just for practicality purposes. I've sliced so many wires up and I've broken up so many things that it's just, I don't do it anymore. But a top battery is preferred. Generally, if you look at the side of the quad, you see the prop disc where the prop actually spins. It's near the top plate on this craft. So ideally, you want to have your center of gravity on the z-axis right on that prop disc. And the reason for that is because when you do rolls and flips, this is the functional area that actually acts on the air and works and makes it stop and makes it go forward. So when you come out of a roll and it does that zip to stop it, it's acting perpendicular to the center of gravity mass. Whereas if your battery is underneath, your z-axis center of gravity is kind of down here. It's lower on the prop disc, and when it comes out of the rotation to do the zip to stop, it now has an oblique arm with respect to the plane of the disc, of the prop disc, to try and stop that rotation. So what this equates to is your PID adjustments are going to be more finicky. When you have the battery on top, the weight distribution on the z-axis is more kind of in the middle of the frame, so it's much easier to tune, and the quad just responds easier with less input. And that's just a matter of life. And then on top of that, when you have the battery on top and you also have the camera on top, when you do rolls and flips and spins, not flips so much, but more rolls, the quad is spinning around this axis at this level, like this. So your rolls in the camera feed look more centered. What that means is that when you do a roll, like the frame looks like it's locked on a target as you do the roll instead of like an oblique kind of wobble. That only works out if you fly at 25, 30, 35 degrees tilt. If you go past 30 or 35 degrees tilt, I mean, all bets are off. You're looking at such an oblique angle already that it doesn't really make a difference. And that's why I prefer this style of frame with the battery underneath also, because I'm always flying at 35 degrees or more. I don't even remember the last time I flew at less than 30 degrees. So no matter what I do, my rolls are always going to look oblique because my camera is pointed at the sky. It's not going to be pointed straight so that it rolls nicely. And I always have to coordinate all my rolls. So then the next debate is going to be the weight distribution. I personally think that weight distribution is more important than any other weight discussion there is. It's more important than your all-up weight. It's more important than your battery weight, everything else. Your quad can weigh 600 grams, 700 grams. If the weight distribution is good, it's still going to fly very well, and they're going to be very controlled. So what I mean by weight distribution, we put so much thought and effort into how much our motors weigh. I mean, right now, if a motor weighs more than 30 grams, it's basically not considered by any experienced pilot. It's just too heavy for us to fly because it's too much weight at the end of the arms. Fine. But we don't consider the frame itself. So people are running 4mm thick frames, and that's a lot of weight at the end of the arm. Even the racecraft frame, which doesn't have all these screw holes, it only has 2 screw holes, it still has a bulk of 4mm mass at the end of the arm. If they had made it 3mm and made the arm a little bit wider to compensate for the loss in strength, you would have less weight at the end of the arms, and it would potentially perform better in the air to control inputs. Now, aerodynamics and everything else, forget about that. But for control purposes and control inputs, it would be a better performing craft. And that's why 3mm is really what any experienced pilot wants to use. They don't really want to use anything but 3mm because it just doesn't perform the same way. And it's not because of the overall weight of the craft, it's because of the weight distribution at the end of the arms. After that, you can consider the weight distribution front to back, but that's really not as important of a topic because we don't really do flips as much as we do rolls. The roll axis on the craft is much more important. That's how we turn, that's how we fly, that's generally how we do all of our tricks, and that's that. So these are two really small concepts that you can kind of blow out of proportion if you overthink it, but generally you want to have lightness at the end of the arms, and if you like flying at a low camera angle, maybe a top battery would be better for you, but it might be impractical because you end up breaking more batteries. Just to show you an example of what a really, really tight Z-axis center of gravity looks like, one of my friends, Rich, at Rich FPV on YouTube, he has designed a frame that uses 15 millimeter standoffs, which is ridiculous, which puts the camera and the battery basically right in the middle of the prop disc. I mean, this thing does rolls and flips so tight, it's unbelievable. I'm going to show you that video right now, and you can go to his page and check it out also. But that's the best example that I have for a top-mounted battery's performance.